After determining the link lengths, now we have the second part of the problem, optimization, finding a mechanism that satisfies the given swing angle and corresponding crank rotation, and the transmission angle is best. Now, the transmission angle, the minimum and maximum transmission angle for a crank rocker mechanism is given by this equation. We have cosine, remember, and if you plot, give theta 0 and pi, you end up with this equation. Now, what you can do is, you can determine select this lambda value, using that lambda value, determine the link lengths. Once you determine the link lengths, plug it into this equation to determine mu max. And plot for several lambda values, you obtain a curve like this. The one that you are looking for is the transmission angle that deviates least from 90 degrees. So maximum mu min. This is the point that you want. And in that case, this is the optimum, lambda optimum. Now, you can do this for every problem and determine this lambda optimum. I'll show you different ways of determining this lambda optimum using Excel during the lecture hours. I'm not going to use Excel examples during this recording. It was Primrose and Friedenstein who came up with another solution. What you do is, it is not that easy, I'll say. You see, we have all these link lengths expressed in terms of let me go to the previous one. All the link lengths are expressed in terms of lambda uv, okay, like this. So what you do is, you plug in those values of A4, A3, A1, A2 into this equation and take the derivative to determine the minimum and then maximum, and then change the variable q to q, which is equal to t squared over lambda optimum 2 squared. And then you obtain an equation, a cubic equation, which gives you the value of lambda optimum. Okay? You take the derivative of cos mu and mu max, and you obtain an equation in terms of lambda optimum in this form. There are three roots, but one gives you the maximum value, the other is saddle point. There is only one root in between 1 over u squared less than q less than t squared, which will give you the lambda optimum value. So the root that lies in between this region is going to give you a solution. I'll show you how you can solve this equation in Excel very easily. Now, one thing, in terms of transmission angle, this curve, this diagram is due to Vollmer in 1959, if I'm not mistaken, which gives you the values of mu and the values of beta that gives you the optimum transmission angle. This is the case. Now, number one, remember that those two equations, limits, these are the limits. In this region, you cannot have a solution. In this region, you cannot have a solution. Because in here, maximum min is equal to 0, and here, maximum min is equal to 0. These are the beta angles, initial crank angles that will give you the optimum. Those are the lines. These are the lines, constant transmission angles. 10 degrees, 0 degrees, 20, 30 degrees, 30 degrees, 50 degrees, 60, and so on. Now, notice something. If you are going to obtain a swing angle, 120 degrees, please do not expect to have a solution in which the transmission angle is greater than 30 degrees. Okay? You have none. There's no solution. If you are going to have, as you go, change phi, this is phi, from 180 degrees, as you go down, as you go up, the transmission angle, the best transmission angle that you can obtain is going to get less and less. If you are searching for a transmission angle larger than 30 degrees, notice it is this region. Let me see. Okay, I think I can draw it. It is this region oh, it's 20 degrees, sorry. I'm sorry. I'm new with this pen, so please forgive me. This is the region. So yeah, that is the region within which you have to search for a solution if you are looking for a transmission angle greater than 30 degrees. That means you cannot have an angular swing angle larger than 120 degrees. If you want a good transmission angle, you cannot have a swing angle greater than 120 degrees. And it has to be centric if you are going to obtain a good transmission angle. Time ratio, notice you cannot have a large time ratio, meaning take phi close to 180 degrees, even if you want to change phi. So you have to lie within that region if the transmission angle is important. But there are cases where you have a crank rocker mechanism in which the transmission angle can be 20 degrees or so because there's no load involved. There's very little load, and you can take care of that. But usually you would like to limit yourself within 30 degrees or so. Okay? This is quite important. Where's my mouse? Oh. Okay. Okay. There are special cases. One is centric 4-bar. Phi is equal to 180 degrees. In terms of beta, the equations for the link lengths reduces to this case, to such a case. In terms of mu min, you can have, I think if I close this, maybe, okay. These are the, in terms of mu min, these are the values for the transmission angle. It's for the link lengths. This is cosine beta. You can define the transmission angle and determine the link lengths. A very simple construction, geometric construction for centric 4-bar is very easy. What you do is you select B0B, the output link length, rocker length. Arbitrarily, you can select it. Draw its two positions with an angle psi in between them. Here is it. Okay. Draw a line passing through BEBF. Select a point A0 and take the crank length half of BFBE A2, okay, and select this point as A0, and this is A extended, B extended. This is the coupler length. The line joining A0, ABE is the fixed link. Now, the transmission angle in this case is pi over 2 minus psi over 2. Since notice you form a right angle triangle, the transmission angle mu is equal to pi over 2 minus psi over 2, and the deviation of the transmission angle from 90 degrees at the two extremes, at these two positions, are equal. But this is not the critical transmission angle, because the critical transmission angle is when A0 AE is along A0 B0. So please don't confuse that. But this gives you the best transmission angle you can have. Now, selecting A0, you can select A0 arbitrarily in this region, and that will define the minimum transmission angle. As you increase it, as you take A0 far away, the transmission angle, minimum transmission angle, will get better and better. Now, this you can see in this chart. You see, optimum transmission angle for centric crank is when A2, A4 is equal to 0, and A3 is at infinity. Okay? So A2 over A1 is 0, and A4 over A1 is 0, and A3 is at infinity. So that is not a solution. In this case, for the centric forebar, the link length proportions are critical. So usually we would say, okay, the maximum to minimum link length must be greater than 0.1 or 10. In that case, you have to be above this line. So you select it accordingly. Another thing, important thing is, for example, as I said, for 120 degrees, please do not expect any solution where mu-min is greater than 30 degrees. Okay? When it's 180 degrees, do not expect a solution greater than, when it's 100 degrees, greater than 40 degrees. This is, tells me that. This time, we don't look for the optimum, because optimum is an unacceptable solution. So we limit the link length proportions according to the problem, and we determine, we select the mechanism